Alright, hello my wonderful students. This is foldable number 1. For this one, foldable 1. This one's going to be of the sine function, and we're just going to kind of go over the basics of how the sine function works. And this is the parent function we have here. This is y is equal to sine of x. I know we've been writing y is equal to sine of theta. So sine of theta is what we're going to do, but just know it can be an x. And I wrote it in terms of theta here. So, and this is the general form without phase shift or moving up and down. Y is equal to a sine b theta. And that's kind of what we're going to go over in this foldable. And we'll cover the sine, cosine, tangent with phase shift in a different foldable. So let's go ahead and get started here. So the first one, all we're really doing for the first one is just graphing the parent function. So we're going to have the form of, so this is the function we have, but this is of the form of y is equal to a sine of b theta. For this one, there a is 1 and the b is 1 as well. So it's, like I said, it's going to be the parent function. Parent function I usually like graphing in terms of in red. So I'll leave my red pencil or pen already up there. Alright, for this one, so what we got to do, we got to find our a and then we got to find our b and then we can kind of graph. So if you guys remember, the a is actually amplitude. A is equal to amplitude. Things with a d. And all that is just distance from the center, and we'll talk about that right now. Since we're not actually moving up or down or left and right, our center is actually going to be this line here. So the amplitude is going to just be 1 up and 1 down. So I can just go ahead and just mark this -1 and mark this 1 because our a is non-existent. So that means our a is actually going to be 1. So our a is going to equal to 1. And then our b is going to determine our period or the cycle that we're going to use. So usually for the period or cycle is 2 pi divided by b, but our b here is 1, so that means it's just going to be 2 pi divided by 1, which is equal to 2 pi. So I know my distance here is going to go to 2 pi. So we're going to start from 0 and go to 2 pi. And if you guys remember, we're actually going to be going over like the points here from the unit circle. If you guys remember the point here, this is, it's 1, 0. This one is 0, 1. This one is -1, 0. And this one is 0, -1. And the points are as follows. Since this is a sine graph, all we're really going to look at is just the y's, because that's in terms of y. Remember, it's cosine of x or cosine of theta, then sine of theta. So if we notice here on our first one here, our point here at 0, we'll split this up first. So this is going to be here, half of this would be pi, because it's the distance from here to here, right? Half of this distance would be divided by 2. Half of this distance from here to here would be divided by 2, so just pi divided by 2, which gives us pi over 2. And then this one right here would be our 3 pi over 2, because all you do is you add pi times 2 pi and divide by 2, midpoint formula, to get our 3 pi divided by 2. Coincidentally, this is actually the same thing as here. 2 pi, or pi over 2, then it's pi, then it's 3 pi over 2, and then we go to 2 pi. So if you notice, we're kind of in the same kind of cycle here. So in order to do this, we're just going to kind of start. So at 0, sine of 0, the sine is, it's 0. At sine of pi over 2, we notice in this it's 1. At sine at pi, it's 0. Sine of 3 pi over 2 is -1. So we go down to -1. And sine of 2 pi is once again 0. So if we were to graph this, make sure you don't graph straight lines because it's actually a curve. So you're going to curve. Nice and good curves. So this is going to be our parent function. Parent function for each one. And I'm going to graph this and kind of each of these, as you can see, and then just kind of show how it looks for each of them as well.